How you doing, guys?
Good.
Good stuff, good stuff. Where's Mr. Roger? No? What? Fine. Hi, right. Are you ready? Can we set off?
Yeah.
Rules. I've got rules. You guys cool with rules?
Yeah.
So enthusiastic. Are you guys cool with rules?
Yeah.
Okay. Right, the rules are really simple. If I ask you a question, you don't have to put your hand up. Just shout out the answer, okay? Cool?
Yeah.
If you want to ask me a question, then you put your hand up and we make sure everybody gets to go. Mr. Roger can make sure that everybody asks a question. And you can ask a question anytime you like all the way through. Alright?
Yeah.
So I've got flies and stuff flying around here. Right, here we go. First question. What's this?
A globe.
Excellent, okay. Put your hand up, put your hand up. Yeah, let's see. Don't put your hand up, just shout out. Right, it's a globe. What shape is it? Brilliant. Just making sure that the globe I'm using here near Cambridge is the same shape as the globe you've got there. Alright, so we're seeing the same heat first. But oh, I can't speak English this morning, it's Monday. Oh no! Right, do you guys understand latitude and longitude?
Yeah.
Cool, but just to make sure we're doing the same stuff, we're going to run through it again very quickly. Right, to measure how far up or down the globe you are, use lines of latitude. They go around the world this way. We'll start the equator, which is 0 degrees, right? So at the top, you've got geographical North Pole, which is 90 degrees north. It's like a right angle. So the equator here is 0 degrees. This is 90 degrees north. So if the North Pole is at 90 degrees north, where's the South Pole?
90 degrees south.
90 degrees south. Easy, you guys got it. Right, so if you're halfway up, 45 degrees north, halfway down, 45 degrees south. Right, then we have to find out how far around the world we are, okay? For that, use lines of longitude. There's one that's really special, where east and west begins. Where is it? Do you know what it's called? Prime meridian? Have you heard the prime meridian?
No.
Okay, the prime meridian goes from the geographical North Pole all the way down to the South Pole, and it goes, if I get the right place, it goes here, it goes through England, not too far from me where I am, and that's 0 degrees, where east and west begins. Everything to the right of that line is measured in degrees east, everything to the left of that line is measured in degrees west. Okay, and then that makes up a grid, and then you can just play like a giant game of battleships. It's cool. Right, I'm going to ask you a question. It's Monday morning, people are yawning. Right, I'm going to ask you a question. How do you find your way to school in the morning?
A bit louder, Leah. Grace. In a car.
You find your way in a car. How do you get there? How do you find the way?
How do you find the way?
You sat down to find your way to school in the morning? You memorize it, okay. Foundation of navigation is memory. Once you've been somewhere once, twice, 3 times, or more times, start to remember the way. And that's the foundation of navigation. But what if I was to drop you somewhere different? What if I was to take you to London, right? I'd drop you on one side of town all the way over here, and I'd ask you to get to the other side of town all the way over here. What tool do you think you'd use to help you find your way? Map. Okay, let's go really simple. Let's go old school. We're going to use a map. Okay, so a map of a city is covered in features, and the features of a map of a city would be things like streets and lanes and roads and motorways, and show blocks of buildings, maybe a few parks, depending on how big they are, and that would make up the features of a map. And then you can work out where to go left and right, straight on, and that's how you'd find your route to the other side of town. Now, if I were to drop you in the middle of the countryside, say up in the north of Scotland or Dartmoor or somewhere similar, you'd still use a map. You'd probably use a map and a compass, and that would help you find your way. The features on the map would be entirely different. The features on a map of the wilderness would be things like contours, so hills and valleys, rivers, lakes, streams, maybe areas of forest deforestation, but remember they can be cut down. And that sort of stuff. Now, when I go up to, most of my expeditions the last couple of years, has been up to the very high Arctic. There's no land mass, it's just frozen seawater. Because it's frozen seawater, there are no features, there are no mountains, there are no valleys, there are no rivers. It's just masses of frozen ice. And my map kind of looks like this. Right, so if my map looks like that, what tool can I use to help me navigate?
GPS.
GPS? Anything else?
Compass.
Okay. I'm glad you said compass. They had said compass. That's brilliant. That's the answer I wanted you to give. That really is the answer I wanted you to give, but it's the wrong answer. Okay, why is it the wrong answer? Can anybody tell me? How does a compass work?
It goes north, east, south, west.
Yeah. But what does it do? How does it work? Where does it work from?
It points to north and south.
It points to north. Magnetic north. It's like a big magnet, right? Needle draws the magnet and it points to magnetic north. The magnetic north pole is like imagine a rod inside the earth, and it moves constantly. So you can see that, you can see the Arctic Circle there. It moves all the time. I think I'm probably wrong, but I think right now it's over in Russia somewhere. A couple of years ago it was over in Canada. So it moves constantly. The closer you get to it, the greater the variation between geographic north and magnetic north. And because it moves all the time, the higher you get, eventually you reach a point where a compass just doesn't work. So, put your hand up to GPS. Excellent. One GPS. This is my GPS. It's mine, there's my initials on the back. This one has been up to the North Pole, it's been down to the Antarctic, it's been in mountains, in jungles, in deserts, in rivers, all over the place, all over the world with me. It's brilliant. Okay, GPS, what does it stand for? Nobody knows. Global Positioning System. It talks to satellites. It seeks to lie. It doesn't talk to satellites. It listens to satellites. Right? There are 24 GPS satellites up in space, and they bombard the planet with signals. And in those signals, there's a data packet. And the data packet is the time that the signal was sent. This is a receiver, so it listens to the satellite. It picks up on the data packet, looks at the time it was sent, and it calculates the distance. Once it talks to 2 satellites in space, it can work out where you are on Earth. The more satellites it speaks to, the more accurate it can become. Once it speaks to 4 satellites, or listens to 4 satellites, it can also tell you how high you are, your altitude above sea level. Right? So really cool maths lessons, look at triangulation, how the GPS system works. So that's what I do, I use the GPS system. Now when I go away, it's pretty cold, right? So I don't really take this out of my pocket all the time. So I use other things, natural phenomena, to help me navigate, to help me stay on track. Who can take a guess as to what they are? Things that happen in nature. I'll give you a clue. Okay, go on, somebody's going to take a guess.
The sun.
The sun! Excellent. Right, I use the sun. Good thing to Google, to look up. Okay, 12 o'clock midday, the sun, if you stand your back to the sun, your shadow, you're facing due north, right? Look up on Google how to use your watch as a compass, or buy my book from Scholastic or any bookshop, and it's in there. So you can use your watch as a compass.
We've got some.
Sorry?
We've got your book.
You've got it?
Yeah.
Excellent. You can't always use it, because in the high Arctic, there's a huge difference between summer and winter, right? In the summer, the sun comes up and it stays up 24 hours a day, 7 days a week. So it's always light. So when I go to bed, when I get in my tent, it's always light. Excellent. Thank you. In the winter, the sun is down and it stays down 24 hours a day, 7 days a week. So it's always dark. So I can use the sun in the summer, it just moves around in a big circle. In the winter, what can I use? Shout out.
Stars.
Stars. Excellent. Anybody know what star I'm looking for?
Moon. North Star.
Star? It's the moon. And press up. Up glass. Right. It's the North Star. North star, also called Polaris, there's lots of names for it. And I find them using two different constellations. The constellations are a name for a group of stars. I use the Big Dipper and Cassiopeia. And if you use those two constellations, you can find the North Star, draw a line straight down, that gives you due north, and from there on you can work out where everything is. Excuse me, let's go shut up. Somebody else has got Australia calling. Right, so I use the sun and stars. Right, it's really cold in the Arctic, okay? What temperature is it where you are today?
18 degrees.
It is
12. 8.
It's not loading. Wait till it for the load to say exactly.
12.
I guess it's 12 to 14. Yeah?
Yeah.
13 degrees.
The temperature is usually anywhere between -20 and -60 degrees. So 20 to 60 below. To put that into perspective, most people's freezers at home are between -16 and -20. So I'm between -20 and -60. So it's really important for me to stay warm. Now, I take everything that I need with me in a pod. So I'm working hard all day. I do 12 to 14 hours of pulling a pod from anywhere from 100 to 450 kilos. And that makes me very hot. So to stay warm, I take lessons from nature. Have you guys ever spoken about animal adaptations?
Yeah.
Oh, so you know all about it. Right. Let's talk about an animal that lives in the cold place. Let's talk about husky, right? Okay, a husky. How does a husky stay warm? It's fur. What about its fur? Thick. What's it like? Anything else on thick? It's what? Very. Yeah. A husky's got layers, right? Next to its body, it's got a layer of fur which is still wavy, all the hairs are wavy, and they interlock. In between those little tight waves are pockets of air. And when the heat comes off the husky's body, because everything gives off heat, those little pockets of air trap heat, trap it next to his body. Over the top go longer hairs, the stuff you see on the outside. Their job is to keep out the elements. So the short hairs keep the heat in, the long hairs keep the elements out. Bear with me 2 seconds, I'm going to show you something. This is a husky. This is one of my huskies. This is West. And I've just pulled a load of hair out. I don't know if you can see there. That's the hair it didn't hurt him. He's shedding at the moment. This is the underhair, the thermal layer at the bottom. Ooh, now he's not happy. I'm covered in hair. Thanks, Steve. He might bite me now. So, I copy that sort of lessons from huskies. So next to my body I wear a thermal layer, like a pair of long johns, okay? But all over my body. And that's, the job of that, covered in hair now, is to keep the heat next to my skin. My thermal layer is made of wool and silk. Wool because it's warm and silk because it's nice and soft. And it's comfortable. When you're wearing the Arctic for several months, you just want to come. Excuse me, 2 seconds. Go on. Okay, please have it. You didn't want to go on TV today. So, down to about -30, all I wear is that thermal layer, and over the top, a Gore-Tex layer, which is like a raincoat, but without any lining. And the Gore-Tex layer keeps the wind and the snow off. Now, if I stop, to give you an idea of how cold it can get, if I stop, I'm just wearing that. After a few minutes, I open my jacket, and the inside of